Okay, so in this chapter, we're going to look at displaying and describing numerical data. So you can see here they counted the number of bedrooms in 24 properties. So the number of bedrooms, that is the numerical data or variable that they're looking at, and then when they say 24 properties, they're telling us n equals 24. So you can see we've set it up in a frequency table here. So the number of bedrooms, 1, 2, 3, and 4, and then we put the frequency, and then they also put the percentage frequency. So the way they would have calculated that would have been the 2 out of the total, 24, times 100 would have given you the 8.3%. And say, for example, this one would have been 8 out of 24 times the 100, which is what gave the 33.3%. Okay, so that's one way we could display it. If we look at this this set of data, we do have a set of numerical data. So we've been given the data in average hours that people worked in 23 countries. So this is the variable. But the way it is numerical to begin with, but then what they do is they change it and place it into here, and this then becomes categorical, the way they're displaying it, because they group it into a group. So if you look through this data, so you can see that between the 30 and 34.9, you had one country with that value, with that many hours. So you can see there's that one. And say, for example, between the 50 and 55, there was 3 countries. So if you look for that, you can find those 3, there's the 3 countries. So that's just explaining. So this, when they worked out the percentage here, they would have said 3 over 23 and times 100 would have given the 13%. Okay, so just be careful though, even though it was originally began as numerical data collected, they have now displayed it and changed it into categorical data by putting it into categories like that. And this would be ordinal because you've got, 30 to 35, 35 to 40 and so on. All right, so we often have this set of data, and we're going to want to get a few what we call summary statistics from it. So when we say that, we might want to find the mean, which is the average of the data, or we might even want to find the median of the data, which is the middle value. So it's like the middle value, so 50% lie above it, and so if you have the value, so if you have your median, whatever that is, 50% of the data is before that and 50% of the data is after that. Okay, so what I'm going to do is show you on the calculator how you could get the mean if you have this frequency table. So if you look here, I know this was a score, say this was how many points they scored in a thing, and then how many people got that score. So here what you want to do is you want to go into your calculator and you want to go into lists and spreadsheets. And you go into lists and spreadsheets from the home screen, you get this page, and we want to put in the 2 lists that we've got in that table. So I put score and I've put each one of them down, and then I've created another list and called it frequency and I've put them down. So it's essentially, we really want one list. What it actually is, you want a whole list where it has, say, 1 4, then you'd have 2 5s, and then you could have 5 6s. So you don't have to, and so on. So you don't have to type all that out. You can tell the calculator that there's a frequency list as well to go with it. So once you've got your list in, you're going to press menu, and you'll go to, same as like what we normally do to get our statistics stuff. So if you remember, you go to menu, statistics, then stat calculations, then you're going to pick one variable, and it'll ask you the number of lists, and it's always 1, and you click OK. Next thing you know, you normally would, if you only had one list of data, you would just pick it here, down where they've done score. But because we've got a frequency to go with, in this section here, go pick your frequency list. Now, because I called it Freq, F-R-E-Q, you can select it like that, and then you press OK, and you'll see you get a list of all your summary values. You might have to scroll up and down to find it, but here you can see here's the mean, and that's 6.4, and if you were to scroll a bit further down, you would see the median value listed and so on. Okay, so a way to display numerical continuous data. So I'm going to say numerical continuous data is through a histogram. Now, I'm saying continuous because they measured the average hours worked, and when we measure that, that's continuous. So here it is. And so they've put it in like this. So they're saying the 30 to 35 is 1. So we can create a histogram, and down here we put average hours worked. So you can see we're just doing a scale along there where we go from like 25 up to 60. And then along in a histogram, then you have the frequencies along the side. So we could, so then we display it. So with a histogram, it's similar to a bar chart, except that we're using numerical continuous data. So that means we have this scale along here. And because we have this scale, there's no gaps in between the bars or the columns. Okay, so there it's represented. If you can also have a percentage frequency, so I just wanted to change this. So if we were to have a percentage frequency, we could do here, so like we could change it, and we'd have a table 1/23, so this ends up being 4.3%. So what you're going to see is this would marry up with 4.3%. And say this one would be, if we converted this to a percentage, it'd be 26.1%. So you'll see that this ends up being around the 26 mark and so on. And this top one was 34.8%. So that's where you could have a percentage and it'll just match like that. All right, so what we want to do is we want to know how to construct a histogram on our calculators. We also want to know how to manually draw one, but here we're going to construct it on our calculators. So you've been given a set of data containing 27 marks in the form of a histogram. So what you want to do is, if we go through the steps, so you go to add lists and spreadsheets. So that takes you to your page like this where we can put our list in. Now you need to give your list a name. Now for exam purposes, you should really try to label it with something to do with the question so that you're not going to mess up and forget, or you can check that question because you've called that list an appropriate name. So because it was marks, I'm going to call it mark, and I called it marks. So you can see there I've called it marks. And then I've entered in the list, so all these 27 numbers. So what you want to do is, because there's 27, hopefully when you get down to your last one, you should be checking that you're on the 27th line when you type in your last digit. Okay, so once you've got your list in, you then click the home page and you then choose a data and statistics page. The data and statistics page is the one that actually has a histogram on its picture. Okay, so you select that one and you get taken to this screen, and this screen will probably originally just be a screen with dots everywhere. And what you want to do is you're going to go down, hover down the bottom, and you'll see it. Then it'll say click to add a variable. So you click enter, and then you'll get a list of all your lists. And we're going to pick marks because that's the one we want. And when we do that, we automatically get what we see here is a dot plot. So it automatically created a dot plot for that data. Now we actually want a histogram. So if we press menu, plot type, and we should get histogram, we'll end up with a histogram, and we can see we've got that histogram there. Now down the bottom, this scaling might not be how we want it. We might want to go in, say, in categories of like 4. We might want to say everyone who got a score from 0 to 4, then 4 to 8, and so on. So way you can change these, the widths of the bars, if you like, is you can press menu and you go plot properties, bin settings, and you'll get equal bin width. So you'll see screens like this. Now the width is like the size of each bar. Yeah, so each bar. So if you want it to be 4, that's why we've put 4. Now alignment is where you want to starting from. Because if you say you were looking at data, say you were recording weights or something, you don't want to start at 0. No one's 0 weight. So you might start at, a little bit under the lowest or whatever. But this one, so we've said we want to start at 2, alignment of 2, and you can see you end up with this. Now you've got a histogram that looks like that, but it's not quite in view. Like we're sort of missing this top bit. So we want to get it in view, and the way you can get it in view is to do control menu zoom data and press enter, and then you end up with this screen like that. So this could be what you could write or draw on your paper as a histogram that you want. Okay, now if you want to change this to a percentage frequency, so at the moment it is simply just a frequency. So if we want to change this to a percentage frequency, we can do that too. We can just simply go menu again, scale, and you change it to percent, and you'll get a percentage frequency histogram. Okay, so now we have these histograms, we need to describe them, because that's all what we're for, is describing what does the data tell us. So we're going to be looking at 3 major things. First, we look at the shape and is there any outliers present. So I've got examples here. So if we're going to call it a positive skewed, that's a shape. So we might write up here. Shape is where you're saying it's either going to be positive skewed, negative, or symmetric. And then you'll also say yes or no to outliers. Okay, so that's the shape. So if you look at positive skewed, you have most of these high towers at the start, and then it goes down and it tails off at the end like that, from going left to right. So that's positive skewed. If you look at negative skewed, we start off with the low values and end up with the high. Okay, if we have symmetric, you can see symmetric means if I draw a middle down the thing, I'll get a mirror image, which I do. And that's why this one is also symmetric, because if I put a line down, we see the same, it's symmetric. Now, often the difference with this one's you might hear it bimodal. Why is it bimodal? Because there's actually 2 modes or 2 peaks there. So we might say that's bimodal, where this one here is definitely just got 1 modal category. All right. Now, we also say whether you have an outlier or not. So an outlier is often well away from the rest of the data. So that's that. Now, when we're going to go, you'll be asked later to talk about the center, and that's where we either talk about the median or the mean. And we might just pop on our notes here, if you like. On skewed data, we would talk about the median. So maybe use median. And same with negative skew, we'd use median. And same with outliers, it would be best to use the median. With symmetric data, that's when we can use the mean. So I'm just using the symbol, that would be when you use the mean. Okay, and spread is simply talking about the range, which we'll have a look at in a minute, or the IQR, the interquartile range, which we'll have a look. So first of all, we've looked at shape there, and we've got some examples. And now the center is like what I said. Now it can either be the median, which is the middle, or the mean. So the mean is this symbol there, okay? So the way we find the mean is we sum the sum of all the data values. So what that means is, if they write it mathematically, this symbol here means sum of, okay? So they often write it like that. So sum of all the x's, so all the data divided by how many there is. So if you want to write it up, you add up all data and divide by total amount of data. Total amount of data, or n, as we know it, okay? Now, the median is the middle value, like what I said before earlier. The median is when you have 50% will be above it, data, and so you have your median and 50% below it. Okay. All right, so to find the median, we often use the formula. So this is to find it. To find median, we often use the formula n, which is the total plus 1 divided by 2 position. Okay, so that is, so say if you had, you add it up and it'll show. We'll have a look in a minute. Now, the median is a resistance statistic not affected by outliers. Because with the mean, we would add up all the values. So when we have these, like, if we have these extreme little values, so if we're thinking about, say we were thinking about our histogram, say I had a little histogram, and we go like that. When we add up all the data, this big value up here will make my mean go higher. So what happens is we'll end up, and we see that when we average it out, we might see that the mean is actually this value here, okay, which is not high. When you find the median, because 50% of the data has to be above or below it, you're going to find the median is down here. Okay, so, sorry, can't write it. So you'll see the median will be down amongst the middle of the majority of the data, because 50% are going to be above it and 50% of the data is going to be below it. Okay, so that's why. Now, so the median is not, it doesn't matter even if there's that one outlier, the median will not be affected. So that's why it's a better measure of center when you have skewed data or outliers. Just so you have the other example, if you had a small outlier and your data higher up, what you're going to see is that small value will drop the mean down low, but your median would be higher up here. Okay, and the spread, when we go to talk about that, is simply the highest value or the lowest. On our calculator, they like to call it the max and the min. And we can also use the interquartile range, which is, we'll learn about in a minute, which is the third quarter minus the first quarter. Just maybe make a little note, this one is also a resistance statistic. It's not going to be affected by it's not affected by outliers, okay, but the range would definitely be affected by outliers, because that outlier is going to be your maximum value. So the range is affected by outlier. Okay, so to find where the mean is, or sometimes we're going to say the standard deviation, which is SX on our calculator, or the 5-number summary on our calculator. So we'll learn about it in a minute. 5-number summary is when we have min, Q1, median, Q3, and maximum. So we need to be able to get all these values on our calculator, and it's in the same spot, and we've done this before. So we've got our list of data. We're going to go to lists and spreadsheets, and we're going to pop our list in. I probably should have given it a name, but they were just saying find the median of all this data. So we popped it in. We've pressed menu, our list. We've pressed menu, stat calculation, one variable, and like we should have given our list a name. So maybe you might have called it X, and we look for X. Select X, your X list, and then you go down. So we'll call that X. So if you scroll down, so we've said here's all our data. We've found here, that is the mean. And this value here is our standard deviation, which can be asked. And we'll often use just the symbol SX for standard deviation. So that's at the top. But if you're looking for the 5-number summary, you just got to scroll down, and you'll see once you can get the 5-number summary all in view. There. Oh, I've cut off minimum. Minimum should be in there. So you can get the minimum, Q1, median, and things. So you can get all the 5-number summary stats in the same place you get the mean and standard deviation. Okay, the histogram below shows the distribution of secondary school attendance rates in percentages for 200 countries between 2010. So this is 200. So we know n equals 200. Now, the data they were collecting, these percentages, that's down here. That's talking about what we're looking at. And you just got to be careful. This frequency table is actually just a frequency, not a percentage frequency. The data they collected were percentages, but it's actually just counting frequency. So when they asked down here, the percentage of countries with secondary school attendance, so percentage, once again, we're going to say it's the amount out of the total times 100. So we know the total, they gave that up there. So we know that's 200 and times 100. But what we're looking for now is, of these 200, which one secondary had an attendance rate of 55% or smaller? So you go find 55%. Here's 55%. So we want smaller. So we want all these categories, how many they are. So if we go and add them up, I'm just going to roughly, so say that one's 9, 15, 20, maybe 18, and 33. So if we add all those up, we get like 95, okay? So we're going to say 95 out of the 200, and then times it by 100, and we get 47.5. So it's definitely not, it's not exact because we were roughly reading them, but you can see the best answer is 46. It wasn't over 50, it's under that, so we'll just go with this answer, 46. Okay, the histogram below shows the distribution of population of 48 countries. So that was giving me the N is 48. The number of these countries, so they just want number with a population between 5 million and 20 million. So go read the scale and you can see here's 5 and here's 20. So we want these 3 categories. It's a little bit light. So I'm going to say that one's 11, this one is 4, and this one is 2. So if we add them up, we've got 17, so I'm going to go B. Okay, when it says what is the shape of this, so we look at, we've got all the data at the start and then it tails out, and then we've got this outlier. So when we have all the data locked up at the start, that's positive skew. with an outlier. Okay, use the following information to answer question 1 and 2. Okay, the group of students was given a comprehension test in which each received a mark out of 50. The results are displayed in a histogram. The percentage of students who received a mark, so remember percentage is amount out of the total times 100. Okay, the percentage of students who received a mark of at least 30, so you go to 30 and we're going to be talking about 30 onwards. So if we labelled up that 30 onwards, we can see if you count all their towers, so we've got 12, 7, 4 and 3. If you count them up, 26. So if we count all them up, we get 26. So we know it's 26, but we need the total. So what I need to do is obviously count up all the categories to get the total amount. So that means I'd have to add all the towers up. So if I add all of them up, I get a total of 80. So I'm going to say 26 out of 80, and I'm going to times it by 100, and I get 32.5%. So I'm going to round to 33, and there's my answer. Okay, so the histogram below displays the weight distribution of 143. Sorry, that got a bit cut off. So I'm going to say 143 birds, which is actually my N, in different living space. So this is just giving a number frequency. Describe the shape of the distribution and note possible outliers. So once again, it's up the start, tailing out. So I'm going to say it's positive skew. And then I'm going to say these are the possible outliers because they're first with, we'll say with possible outliers at, and we will just mark it so it looks like 11,000. Oops, and 12,000. Okay, what percentage of these birds, so percentage equals amount over total times 100, and we know the total was 143. So let's have a look. What are they asking? The amount of the bits less than 1,000. So here's 1,000. So less is just that category. So if we read off that, it looks like 102. And if we times that by 100, so we end up with 71.3%. Now it's set to 1 decimal place, so that's why I did. Okay, so a couple of exam questions on histograms. So the number of families were surveyed to see how many cans of beans they consumed in 3-month period. The results are shown in the above histogram. The percentage of these families, so percentage, we're going to know when we've got to do the amount over the total times 100. Okay, so the percentage of these families surveyed that consumed more than 15 cans of bean. So 15 cans of bean would be this way. So if you count up, this one was 25, this one was 10, and this one was 5. So if you count up all of them, you'll see that that's the amount. So which we have is 40. Now you want the total. So if we look for the total would be adding them all up. So what I mean is 5, 15, 30 thing would be the total, which ends up being 90. So we're going to say out of 90, then we'll times it by 100, and we end up with 44% closest to. a nice easy one to end with. What is the shape of this distribution? So you can see we have the tail at the start this time, and then it gets up big, and that is just negative skewed.